Today's lesson is a short lesson on precipitation. We're just going to talk about the different types of precipitation and how we get them. And basically what I'm going to use are these little diagrams. They might look a little confusing, but I think I can explain them hopefully to show you what they mean. So we'll start with this first one here. And what you see with it is, this is altitude, so increasing elevation or altitude. And this is temperature, so getting colder to the left and warmer to the right. And this dotted line is the temperature in the atmosphere. So in this one, you see at the surface, it's like 25 degrees Fahrenheit, below freezing. As you go up, it stays colder than freezing all the way up through the atmosphere. So this one is snow. And you see in the picture here, it starts off as snow or ice crystals because it's really cold up here. As it falls, it stays cold the whole way down, and it's snow. We compare that to this picture. So this picture, it's cold at the ground. As you go up in altitude, though, there's going to be a little inversion, a little warm layer. But it's a shallow warm layer. So a little warm layer. And then at the top, it's cold again. So we have our cloud here. And because it's below freezing up here, it starts off as ice crystal, starts off as snow. So the snow falls. It falls into this warm layer, and it's going to melt into rain. So now it's rain. But then, before it hits the ground, there's this cold layer. And it's going to refreeze into now pellets of ice that we call sleet. So this one is sleet. So that's how sleet forms. This one down here you see is a little bit different. Same idea, cold at the surface, cold at the top, but now the warm layer is really deep. So there's a really deep warm layer. So what happens is, again, it starts off usually as snow, but then it's going to melt into rain for this warm layer. It gets cold at the surface, but it's not thick enough to freeze in the air. So this rain is going to hit the ground, but the ground is going to be really cold, and it's going to freeze into a layer of ice when it hits the ground. So we call that freezing rain. That is the really bad stuff. Okay, that's when you get a sheet of ice covering everything, and school is closed for multiple days. Okay, this is really bad stuff because, like I said, it's not just pellets of ice that you can sweep out of the way. It's just going to be a sheet of ice covering everything. Power lines, trees, sidewalks, roads, everything. The rain falls as a liquid, hits, and then freezes into a sheet. Rain, I didn't draw rain, but rain is just, warm. Okay, warm going up. This last one here is a different kind of picture. This is for hail. So what I want to show you for hail is not, like I said, not necessarily in the upper atmosphere like this, although it is cold in the upper atmosphere and warm at the bottom. I want to show you how it works inside of a cloud to make hail. When do you get hail? Do you get it in the wintertime? Fall? No. You usually get hail in the late spring or early summer because you need really strong cold fronts. And when you get a really strong cold front, you're going to get a strong updraft. And that's going to make a vertically developed cloud. You should know the vertically developed cloud. It's a cumulonimbus cloud. So I'm going to draw a big cumulonimbus cloud with a big anvil head, like that. Okay, so the big cumulonimbus cloud, here's the ground. And again, the reason why this is so tall, it's vertically developed, is there is a really strong updraft. Okay, so that's a really strong updraft, lifting that moisture up and making this huge cloud. Well, what happens is you have a little piece of ice, and that piece of ice, let me actually change colors. So that piece of ice is going to fall through the cloud. As it falls through the cloud, it hits cloud droplets, and you get a layer of water surrounding that ice crystal. It goes down, and it's going to hit the updraft, and the updraft is going to blow it back up. When it blows it back up, that layer of ice will freeze. Well, then it falls back down, and it picks up another layer of water. It hits the updraft, goes up, that layer of water freezes, falls down, gets another layer of water, blows up, freezes, falls down, goes up, freezes, keeps happening over and over and over again. So every time it falls down and blows up, it's getting another layer of ice on it. Eventually, it's going to get so heavy that when it falls, it can just fall right out. It's too heavy for the updraft and fall down as a big hailstone. or sometimes it can actually get blown out the anvil head. So you could be standing over here, nice bright sunny sunshine, and all of a sudden a big hailstone comes and hits you. It happens. I've experienced it. Probably a lot of you experienced it too. You also experience it with big raindrops. So maybe it's not frozen, maybe it's just big raindrops, where it's nice and sunny, and all of a sudden big raindrops will start splatting around you. And if you look off into the distance, you'll see a tiny little cumulonimbus cloud, and it's just spitting the rain out the anvil head, or the sleet. Or the hail out the anvil head. So that's how a hailstone forms. So if I would cut open a hailstone, what would it look like? It would look kind of like an onion or tree ring. So it has lots of layers. And here are some different pictures of some hailstones. Here's one that's cut open. Again, you see these rings. So you could do it like a tree. You could count how many times it went down and up in that cumulonimbus cloud by how many rings there are. Some of the sizes of hailstones are pretty amazing. This was one of the biggest ones in the U.S. The Coffeyville Hailstone is somewhere near 7 inches diameter. This is a really big one. This fell in China a few years ago. It was about 8.5 inches in diameter, almost 2 pounds. Okay, so almost 2 pounds, just under. The biggest hailstone ever recorded that we know of actually fell in Bangladesh in 1986. We don't have the exact size measured, they didn't measure the size, but the stories say it was the size of a pumpkin. They did measure the weight of it though, and they found that it was 2.25 pounds. And that's the largest, or the heaviest hailstone ever recorded, and we think the largest in size also. So China gets a lot of really big hailstones, Bangladesh and India get a lot of really big hailstones, and then the US gets a lot of big hailstones too. They can be deadly. Not very many people have died in the U.S. from them, um, but in China there have been no cases, and in Bangladesh there are definitely cases. That one hailstone, the one hailstorm that had that biggest one in, I think they said there was 96 reported deaths by hailstone from that. The hailstorm in China that this one came from, they say up to maybe 200 people were killed by these giant hailstones. Um, they're hard, they're heavy, they're falling really quickly. Okay, that's our short little lesson on precipitation.